few years ago, a rainwater harvesting shed and gravity drip irrigation project was implemented in Yardley Chase community in the parish of St. Elizabeth. Under the project, 35 farmers each receive a system. This project was funded by Food and Agricultural Organization, FAO, and implemented by the Emf Water Management Unit in the Rural Agricultural Development Authority, RADA. The purpose of the project was to reduce the impact of drought in the farming community. This technology is adaptable. Hence, a similar project was implemented in Mount Erie community in the parish of Clarendon, where 20 farmers also benefited with this technology. The project was also funded by FAO and implemented by RADA. What is rainwater harvesting? Rainwater harvesting is collecting and storing rainwater for future use. There are various types of rainwater harvesting systems. However, the one that is being featured here is the rainwater harvesting shed. In terms of constructing a rainwater harvesting shed, a suitable location should be selected. The measurement of the shed here is 9 feet wide by 11 feet long. The roof of the shed should have a gently slope toward the section where the gutter will be attached. It is very important to note that the height from the level of the lower end of the roof to the surface of the tank base should be at least 9 feet. How does a rainwater harvesting system shed works? The rainwater goes onto the catchment area, which is the rooftop, flows into the gutter, which goes down the downspout into the pipe and flows into the storage tank. What are other benefits of a rainwater harvesting shed? There are a number of benefits. The rainwater harvesting shed is multifunctional. For example, it is used as shelter for farmers and their workers. It's also used to store seedlings for a short period. It is also used for other storage purposes. And in addition, which is also important, it complements the gravity drip irrigation system.
Now the second component of the rainwater harvesting system is the tank base and the tank. But it is important to ensure that the tank base is constructed properly. Firstly, you have to take into consideration that the tank is 8 feet 6 inches tall and the diameter is 5 feet 4 inches. Now, 1 gallon of water is roughly 10 pounds. So when this tank is full to capacity, that's almost 10,000 pounds of water. Ensure that the tank base is built 6 feet by 6 feet. Lands, the height of the tank should be minimum 3 feet. The reason for this is to ensure that you get 2 psi at the end of the dripper so the plants can get sufficient water. Now 1 foot of water in height gives you 0.433 psi. So when you work out the 3 feet plus the 8 feet 6 inches of the tank, you'll be getting over 5 feet psi for the tank. Now what we tell persons that you don't necessarily have to build a tank with blocks and all those fancy materials. If it's a case where you have stones or other material, it can be used. But you have to ensure that the material is firm enough to hold that 10,000 pounds of water. When you reach on the slope, then you have a different approach because the slope now taking into consideration the PSI. So the steeper the slope is, the lower the tank base should be. Now from the tank, we'll move on to the gravity drip irrigation system. Now for this system, it's fitted with a water meter. Now the aim of a water meter is to ensure that a farmer can track the amount of water he uses for a crop, and also to check in the morning to see if anybody actually steal any of his water out of his tank. Now this system, as Mr. Rome mentioned, is an upgrade to the one in RADA. It's fitted with a fertigation system. Now these farmers were doing what we call hand watering. So they would physically have a bucket or a bottle and move from plants to plants to ensure that they get water. Now with the drip system, that is out the way. But we also wanted to improve the plant nutrition. And plant don't eat, plant drink. So we fitted it with a simple fertigation system, which is made of some 3/4 inch PVC pipe fitted to the filter using a PE threaded tee. Now it is important that you have a filter on the system, and this is just a simple screen filter. So this filter is used to prevent fertilizer sediments, leaves, or anything from going into the drip system. And what we simply tell farmers to do, ensure that you wash it out and use a soft toothbrush to just brush it off to remove anything from it, right? And we just connect it back quickly. We have our PE32 hose that's coming from our filter. So this is a 3/4 to 32 male adapter. The reason why it's a male is because the threading is on the outside, right? As opposed to this one, which is the same thing, right? It's a elbow adapter, but this one is a female because the threading is on the inside. So these are some of the little things that we do out there to ensure that the farmers know exactly what the irrigation fittings are. So right here, the fact that we are doing 2 sections. Now, if you realize this hose is bore. Now, if we should run one hose go right down, then you will have a reduction in the pressure for the bottom section. So what we need to do, and what we did right here, was to put 2 control valves. So we actually run 2 hoses down, and then we actually bore the top section. So if you realize, if a farmer wants to irrigate the bottom section, he just turn off this section and turn on this one. And he can, and vice versa. Now, for the connection of the drip hose, it is important that the drip hose is connected to the PE hose safely, and this is a hydrogal hose. So it is bored to the side to ensure that you put on the head connectors, and then you run your drip hose across the slope to ensure that you maintain maximum pressure. Now the importance about running the drip line across the slope is to ensure that you have uniformity going forward. And it's also important to know that your drip line should not be more than 100 feet because it's a gravity drip system. And in order to maintain your 2 psi pressure, you don't need to go above that. Once you start to go above that, then the amount of water the plant gets will be reduced, and then you'll have some issue going forward. So if you realize this plot is sloping that way, and the irrigation line or the hydrogal line comes right across the slope. Now, if we were supposed to run this line down the slope, then when you start to irrigate, most of the water will remain, when you turn off the system, most of the water will remain down there. And even in most cases, these plants up top here will not be getting any water. Number 2, when you're doing your fertigation, those plants on the bottom will be looking good because these are not pressure compensated drippers. And then you'll have issue where toxicity is concerned, because a buildup of nutrients will take place with those plants down there while these up here will be starving. Now at the end of the drip line, you have to ensure that it is firmly in place. Right, so you use your end bung or your stop right? And you have to ensure that you bend your hose. So this is your stop. Put on the hose, bend it, put it on, and then you secure it. But guess what? You would not put this stick between here, because if you put it here, then over time it might go this way and then you might start to lose water here. So you need to ensure that when you are securing your drip hose, it is done right here. And you can use a card to help secure it. The benefits of the drip irrigation system. One of the ways that we are going in agriculture is what we call precision farming. And one, with the fertigation system, plants are getting the nutrients in the right form, at the right time, at the right place. Two, it allows for crop diversification, because there are farmers who usually plant like pumpkins and cucumbers who are now doing hot peppers and tomatoes. Three, it allows for farmers to produce and make good money in dry time. It also allows for a longer harvesting period. And finally, farmers get better quality produce from their farms.